Assalamu alaikum. Welcome to another video. Today we will discuss chapter number 6 of class first year and the topic is Bernoulli's equation. As you all know that this is a very important topic for FPISC exams or BISC exams. So let's start with it. Bernoulli's equation was invented by Daniel Bernoulli. This equation states that the whole energy, that is mechanical energy of the moving fluid, which includes gravitational potential energy of elevation, fluid pressure energy, and the kinetic energy of fluid motion remains constant. This is a fundamental principle in fluid dynamics and it basically describes the conservation of energy in a flowing fluid. It has many practical applications that will be discussed at the end of this lecture. So let's start with the mathematical relation. The mathematical relation states that the sum of pressure energy, kinetic energy, and potential energy remains constant along a streamline. Let's derive this equation, but first we need to understand its diagram. As you can see in the diagram, the fluid is moving through a pipe of varying cross-sectional area labeled as A1 and A2, as well as varying height labeled as H1 and H2. You can also name it as Y1 and Y2. So the pressure will be changing along the pipe and the distance covered by the fluid will be labeled as delta x1 and delta x2. Some of the key assumptions that you have to keep in mind while deriving this equation are that the fluid is incompressible, as well as it is steady, means it does not change with time. The fluid is non-viscous, means there is no internal friction, and the flow of the fluid occurs along a streamline. Now let's derive the Bernoulli's equation. As we know that pressure is defined as force per unit area, so from this we can derive a relation for force on upper and lower ends. So the force on one end of the fluid is defined as a product of pressure and area. Similarly, the work done on the fluid will be defined as a product of force and distance. So we will have the equation number 2 as the work done on fluid. By substituting the value of force from equation 1 in equation 2, we will gain a new relation for work done. Similarly, on the other end of the fluid, the force and work done can also be derived. Now, W2 is taken as negative because this work is done against the fluid force. So, the net work done will be equal to the sum of W1 and W2. We will add both of these work done and get the equation for net work done. Now let us define the velocities at both ends as V1 and V2, and we know that distance is defined as a product of velocity and time. So the equation 5 becomes, as we know the equation of continuity, by using this equation of continuity and multiplying it with time will give us volume, because volume is equals to area into distance. So using this relation in equation 6 will derive a new relation that will be W is equals to P1V minus P2V. We will take volume as common here, as we know that volume is defined as mass per unit density. So by using this formula for volume in the above relation, we can derive a new relation Now, a part of this work done is utilized by fluid in changing its kinetic energy, and a part of it is utilized in changing its gravitational potential energy. So we will gain two relations, one of which is change in kinetic energy and the other is change in potential energy. By utilizing both of these relations in work done formula, we will get a new equation. So by solving this, we will get the final relation for Bernoulli's equation. As we know that there are several practical applications across various fields including engineering, physics and environmental science. So here are some key applications. Number 1, aviation. Bernoulli's principle explains how lift is generated on airplane wings. The air moves faster over the curved upper surface of the wing, thereby creating lower pressure compared to the underside, resulting in upward lift. Number 2 is Venturi effect, that is flow measurement. Venturi meters and orifice plates use Bernoulli's principle to measure fluid flow rate. So for this, a constriction in a pipe causes fluid velocity to increase and pressure to decrease, allowing for flow rate calculations. And number 3 is medical application, that is ventilators. So ventilators use this Bernoulli's equation, this principle, to regulate airflow and pressure. Thank you.